Hello, everyone. Good morning, afternoon, or evening. Dear authors and invited guests, welcome to Technical Session 11B. My name is Alesha Mullah, and I will be your moderator for this session. On behalf of Global Knowledge Research Foundation and GR Scholastic, it is my great pleasure to welcome you to the 11th International Congress on Information and Communication Technology, ICICT 2026, London, UK. The 11th edition of the conference is being organized in a hybrid mode. The physical event was held on the 24th of February in London, and the virtual event is being held from 25th to 27th February via Zoom. I hope you will enjoy the knowledgeable and interactive sessions throughout the day. In this session, we will have 6 presentations. Each presenter will be given 12 minutes to present and 3 minutes for question and answer. On the 10-minute mark, I will raise a gentle reminder. There is another request to all the participants. Please stay connected with us till the closing remarks. If you have any query or update, then you can write it to me in the chat box. Just before we start, I would like to introduce you all to the chairs for this session. Our first chair for today is Shakir Karim. Shakir Karim is a lecturer and unit coordinator in the School of Engineering and Technology, SET, at CQ University in Australia. His research explores the intersection of information technology, business, and emerging digital trends. His published work includes studies on cybersecurity and e-commerce, as well as research on the impact of artificial intelligence in transforming the Australian healthcare sector. I now request Mr. Karim to please say a few words.
Thank you, Alicia. Thanks for a nice and wonderful introductions. It's great to be here. It's my extreme pleasure to be part of these conferences and at the same time to be part as a session chair, technical session chair. We will have 6 presenters, 6 wonderful presenters, I believe, and we will learn plenty of things. It will be a very, very informative and knowledgeable sessions that we believe. So let's kick off.
Thank you, sir. Our next chair for today's session is Dr. Pradnya Chitrao. She is a professor at Symbiosis Institute of Management Studies in Pune, India. An experienced academic with a strong background in the education management sector, she is skilled in soft skills development, e-learning, lecturing, organizational development, and instructional design, contributing actively to teaching, training, and academic innovation. Dr. Pradnya, I request you to say a few words.
Thank you so much for the nice introduction. Hello, everybody. And thank you very much for inviting me to be one of the session chairs. I look forward to some very interesting presentations. Thank you.
Thank you, ma'am. We will now begin with our first presentation for today. Our first presenter is Mentor Arifaj, who will be presenting an inclusive edge-only ICT framework for AI-enabled predictive maintenance in SMEs. You may now begin.
Hello, I'm Mentor Arifaj. Thank you for having me today. So today we're gonna present an inclusive edge-only ICT framework for AI-enabled predictive maintenance in SMEs. Hope the topic gonna be relevant and interesting to all participants. Thank you. So did you hear me, or I need to speak more loudly, or?
We can hear you.
Okay, so should I get started with my presentation?
Yes, you may.
Okay, thank you. So sharing the screen. If you don't see it, please let me know.
We can see.
Thank you again. So I will start and try to stick within your time limits. An inclusive edge-only ICT framework for AI-enabled predictive maintenance in SMEs, together with Professor Ishaq Shabani from University of Pristina. We did a framework that we are going to present today, that it's edge-only and it includes AI for predictive maintenance. First of all, what's the problem with SMEs, or why SMEs are struggling to adopt AI-enabled predictive maintenance? In fact, there are cloud-based systems, but for SMEs, usually they have recurring costs and IT expertise required. As we know, most of SMEs, they have limited resources like financial, technical, or expertise resources. So usually cloud-based systems might look like very unaffordable. Hybrid solution as well required still stable connectivity and skilled staff, and need for SMEs there is a need to have more affordable, autonomous, predictive solutions. Our research objective is to design and validate an affordable predictive maintenance framework that enable AI inference directly at the edge and operate independently from cloud infrastructure that support as well gradual digital maturity of SMEs. So basically, we are proposing a solution for this edge-only ICT framework that runs on microservice-based architecture. It's vendor-neutral, open-source technologies run entirely on low-cost edge devices. In our case, we utilized Raspberry Pi 4 and simulating nodes via ESP32 to simulate industrial telemetry data. Our proposal or proposed framework, we are trying to use minimum viable architecture that to use only those components that are needed to be run on edge only. And these components are data entry service, that MQTT ingestion, data service or SQLite storage, inference service, ONNX runtime, event processing service rule engine, and notification service MQTT alerts. This is also a diagram or a figure of this main components or 5 components that are running on microservices to run the framework. So ESP32 is simulating telemetry data and ingesting to MQTT of Raspberry Pi, and then data ingestions and data to inference, and save time, data storage, save them, and output of inference goes to event processing, or event processing interprets the output of inference and then raises eventually notification via notification service to user. Edge-only deployment model. So this model that, or the framework that we have represented, while we deploy to Raspberry Pi 4. In our case, we had Raspberry Pi 4 of 8 GB. All 5 services were deployed there. We utilized local MQTT broker or Mosquito, and this framework has no cloud dependency. Everything runs on edge, and it's autonomous and resilient operation. Prototype and experimental setup. What we did, we utilized one ESP32 that simulate up to 20 machines, and 1 telemetry record per second per device. And we generated 4 parameters: temperature, vibration, rotation per minute, and power. We used isolation forest model trained offline, the if model we trained offline, and inference, it is done via ONNX runtime at edge. Performance metric that we have achieved while we were simulating 20 devices, we had a latency of P50 and P95 of 46.8 or 54.9 millisecond. CPU usage 68.5%. RAM usage was 0.7 GB, and throughput was about 18 kilobytes per second, and the kind of accuracy was around 0.87. Key findings. So as we have seen from the values earlier presented, we have seen that inference was nearly real-time anomaly detection, less than 55 millisecond per P95 or most of the telemetry data. Stable resource utilization on low-cost hardware. So we have seen that we are not utilizing in maximum the CPU or RAM, and result in general could be accurate or comparable accuracy to cloud-based systems or hybrid-based systems and full offline. So AI inference feasibility is confirmed by this result. Also, security at the edge. So MQTT ran over TLS, encrypted storage, and signed firmware microservice updates, and a reduced attack surface for SMEs. So in general, we have taken into consideration and security at the edge as well. Cost analysis. So for this pilot, for 20 machines, we utilize sensor layer, or if we are going to get these ESP32 nodes, including sensors, of course, you could buy up to €1,000. Gateway layer, for redundancy purposes, we could utilize 2 Raspberry Pi 4, which may cost up to €190. So total capex, it's 1,200. Whereas the maintenance, it's very low cost, which could be around 100 per year. That could be considered the energy or eventually the maintenance, like replacing any sensor or anything else. So in general, with this, we have no cloud subscription cost. So adoption and expansion maturity path. So phase 1 that we have already represented is edge-only deployment. Hybrid expansion is possible, so could for some cloud analytics, and full, eventually some of those components could be expanded to cloud as well. Limitation, of course, we ran this prototype using synthetic dataset validation, NASA CMAPSS based, tested only on Raspberry Pi for hardware, static pre-trained model, so no online or time to time or pre-scheduled training, and validated up to 20 machines only. So this comes as well to a future work. So deploying in real factory environment, one of them, to see how it's going to reflect based on real factory environment, and support online or scheduled retraining, stress test with more devices like 50 or 100. It depends on feasibility, and distributed interface inference, like eventually not only to concentrate the inference in Pi, but also in ESP32 for some critical values or very quick findings, and advanced hybrid edge cloud orchestration. Conclusion. So in general, this is one of inclusive or affordable AI-based predictive maintenance, fully operable at the edge. Microservice architecture ensures modularity, low latency, solid accuracy, and low cost in general, and practical entry point for most of SMEs digitalization. Of course, this may include also micro enterprises and startups as well. Thank you very much for your attention, and now I'm open for discussion.
Hi, mentor. First, this is Shakir from Australia. I just have one generic question. Can you hear me? Can you hear me, mentor?
Yes, please. Yeah, definitely.
Okay. Yeah. I just have a generic questions. Your edge-only ICT frameworks, is it only applicable for small to mid-sized enterprises, or we can think about large and complex enterprise?
In fact, what we did so far, we tested only up to 20 devices, and usually large enterprises, they have, let's say, hundreds or even thousands of devices. Of course, this one could be applicable with some extensions, like connecting nodes or having an extra node that's gonna connect other different nodes in order to synchronize, to maintain, and to get the results eventually.
Thank you very much. That's all from me.
Yeah. Also, in going ahead in what you have to say, I would also like to know whether this is actually something which is affordable in low income and small enterprises, actually, because the cost factors which you have mentioned might be actually high for small enterprises and for low income.
So when it comes to cost here, so
Yes.
we estimated and did the cost analysis for let's say one SMEs with up to 20 machines, but eventually the cost is going to be reduced if one SMEs or micro enterprise might have, let's say, 3 machines or 4 machines. So the price was giving up to 20 machines. And of course, this is kind of hardware that may cost them eventually, if they want to implement such predictive maintenance and AI enabled.
Okay, thank you so much.
Thank you. Our next presentation will be by Alexander Yanish, who will be presenting Concept for a Monitoring System to Assess the Health and Stress Tolerance of Boars During Sperm Collection. Alexander, you may now begin.
Yes, thank you. Let me share my screen. Okay, can you see the presentation? Yes, can you hear me? Loud and clear? Okay, perfect. So, good morning, everyone, and thank you for the opportunity to present our concept here. My name is Alexander Jenisch, and I am working as a research associate for the HTV Berlin. It's a University of Applied Sciences in Germany. And I work on a research project called Vital Checks for Pigs. And in this project, we are developing an AI-based system for health monitoring of breeding boars. And today I would like to briefly introduce you to the concept behind this system. So let me give you a little bit of background on the topic. So in Germany, more than 95%, more than 95% of all sows are artificially inseminated. And we have approximately 1.4 million sows in Germany. And one single sow can give birth to up to 15 piglets, and twice a year. So a lot of pigs. And the product, in other words, the semen for the artificial insemination, comes from specialized artificial insemination centers where selected male pigs, called AI boars, are kept under controlled conditions and used for semen collection. And there's only around 10,000 AI boars in Germany. I'm sorry, one moment. A little bit sick. So, so here, I'm sorry. Here on the right side, it's really hard for me to talk because I'm sick. Here on the right side, you can see a screenshot from a German newspaper article to give you an idea of the scale. So it translates to boar Puck produced more than 140,000 offsprings in the last 11 years. So in exceptional cases, one AI boar can produce well over 100,000 offspring. That means that these animals are extremely valuable because the quality and reproductive performance of the collected semen is crucial for the economic success of many companies in Germany. So similar to humans, key factors influencing the semen quality are, of course, the health and the stress status of the boar. So physiological strain, pain, diseases, and also environmental influences. All these are factors that have can have a negative effect on the semen quality and fertility. Therefore, continuous health monitoring in such facilities is very important in order to detect potential problems at an early stage, especially because diseases can spread over the semen to sow farms. Yeah. And as you can see in the other picture, these are very large animals. So sometimes they weigh up to 400 kilograms. And I have visited a barn myself and was surprised. They're as big as a small car, basically. And sexuality in the animal kingdom is always connected to some degree of aggression. So a clinical health examination is it's always associated with some kind of risk. And the animal often needs to be sedated or restrained, which again causes stress for the animal and also has an impact on the measurements. As a result, continuous health examinations are very difficult and diseases often detected late or when the disease already has spread in the barn. So for this reason, there is increasing interest in digital systems that use health-related data, for example, cameras, microphones, or vibration sensors. And this is basically exactly where our concept or project comes in. So our goal is to develop a health monitoring system specifically designed for those facilities and the valuable animals. And we aim to measure vital parameters such as temperature, heart rate, respiratory rates, and also stress hormones, but non-invasively, so without basically touching the animal. And during sexual activity. And the collected data will then be analyzed by machine learning algorithms, and we will try to assess the health status of the individual animal, but also of the whole herd. And ideally, this will, of course, contribute to a healthier welfare for the animal and also increase biosecurity and also productivity within the facilities. So here you can see a very simplified overview of the system context. During multiple semen collections, vital parameters are recorded, and the measurements data is then enriched with other data from the barn and the station, and then transferred into a shared data pool. And after that, the data is analyzed using machine learning methods. And finally, the insights are provided to the end user through an early warning system. Okay, so how is the data acquired actually? So in such facilities, the AI boars are typically provided twice a week. And on the production day, the boars are guided from the stable into some special area or a special pen. And the pen is equipped with something called a boar phantom. And here in the center image, you can see such a phantom, which is essentially an animal-like dummy, which triggers a reflex in the boar. So the boar mounts the device voluntarily and remains there while the semen is collected, either manually or automated. And we take advantage of several characteristics here. So first of all, the boars have relatively long ejaculation times, up to 10 minutes. And secondly, during ejaculation, they remain almost motionless on the device. And third, it's an absolute routine process for the animal, which doesn't cause any extra stress. So our concept includes the development of a smart boar phantom by integrating sensors into this sow dummy. And as you can see on the right side, for example, you can see that we integrated ECG electrodes into the dummy to measure cardiac activity. And in addition, we recently integrated sensors for temperature, contact pressure, as well as an I hope I don't butcher the pronunciation, accelerometer, to research how the respiratory rate can be measured reliably. And as you can see, we also tried out different positions to see what is good for data measure. And yeah, the measured data is then combined with many relevant influencing factors in a shared data pool, and this includes station data, for example, age, breed, weight, etc., but also external data such as weather conditions. This is very important because boars have very unique characteristics. For example, they have heat stress in the summer, so additional data is needed to explain this variance later. And also there is production data included, and this is because after every production, every sample is directly examined in a laboratory for quality parameters. And this is not only for our project, but this is really the standard process. So that is also the reason why the concept includes the development of a rapid test to assess stress hormone levels, which will be then integrated into this process, basically. And together, all these data sources, they form the basis for the analysis. So what happens next? The data has to be prepared, processed, and analyzed. And this means we first need to evaluate what is usable and valid, and especially with regards to motion artifacts, measurement gaps, and other interferences. So the data is really extremely noisy. And here on the right side, you can see an ECG signal from an initial field test, which was filtered, smoothed, and in order to extract relevant features, such as the R peaks in the ECG, to determine the heart rate. But this, of course, is a really noise-free cutout. Usually the data looks a little bit different. But this field test already confirms the technical feasibility of continuous and stress-free vital parameter acquisition under sexual activity. And I would like to emphasize here that that by itself is already a really nice accomplishment, as this is something that has not been possible before. And it was not clear if it could be achieved because retrieving ECG data in this environment is so much different from retrieving ECG data from a human. Boars are very hairy. You cannot use any gel. It's a wet environment. You cannot tell the animal to stop moving. So it's a really nice step forward. And within the framework of the concept, we plan to implement an anomaly detection. Now, why anomaly detection? Because, for example, for predictive modeling or classification of specific pathological states using machine learning, you need a lot of data and also documented disease cases. And since this is a completely new product, we do not have any historical central data. And furthermore, these animals are generally healthy young males in their best age. So during the planned data collection phase of 4 months, we cannot expect sufficient number of disease cases. So, and on top of that, if a disease appears, production will be stopped immediately. So the production data will not be available anyways of sick animals.
Excuse me, I'm sorry to interrupt. You have about 1.5 minutes left.
How many?
1.5.
1.5. Okay, yeah, I'm almost done. So yeah, we used to, that's the reason why we plan to monitor the vital parameters in relation to other contextual data and detect deviations from the normal pattern. So we plan to use classical clustering algorithms to establish breed-specific vital profiles, and for anomaly detection, semi-supervised learning, because that appears the most promising. Those can handle highly imbalanced data sets, such as ours will be, which means we have a lot of normal data points and a few anomalies may be labeled by our veterinarian. However, since we are still in the beginning, we haven't really chosen a final algorithm because it will strongly depend on the data availability and quality. Yeah, really short, like this is how the architecture looks like very simple. Left side, you have the Bohr phantom with the sensors. The communication module is just an Arduino Uno, which has a Wi-Fi, with Wi-Fi enabled and sends the data to our server directly to the cloud where the data is processed. put to the database. We have another service that uses the machine learning and writes the results back into the database. And then, of course, the user interface, which presents the results to the end user. And yeah, right now we are currently implementing the concept. We have started with the field tests, of course, but yeah, we have to test the infrastructure and a long-term test under real conditions. Then we do the data collection, and the goal is, of course, to implement a working prototype and hopefully present it here again in the future. That's it. Thank you so much for listening. If you have any questions, I'm happy to answer those.
I can ask a couple of questions that came in my mind. Thanks. First of all, Alex, wonderful presentation and a very interesting topic. One of the questions just that came in my mind, is there any particular reason that you have selected the boar? Can I apply this kind of concept in any other animal?
Actually, you could also implement it for cows, actually, for bulls. But this was just because we had this cooperation partner, and it's also really hard to get in touch with them and make them share the data. So this was our best approach. So we have the companies basically that work with us and made this possible.
Thank you. And I believe that ethical clearance needs to be approved, right? Before you do further research, because you are dealing with the animal.
Actually, in our case, it doesn't have to be, because it's completely non-invasive. So we are not actually interacting with the animal, because it's a routine process, and this is also the goal, like to not put any stress on the animal, just integrate it into the routine process.
Sure. Just one more last question, Alex. As a general research community, how we can get some benefit from this research, from the research community?
Yeah, so I can just, so when I was researching for this project, of course, I was also looking for what has been done before. Are there any sensor-based solutions already? And also we found also like vibration from the floor. And so that's what I said. I want to emphasize that this is already a great step forward, that we can have an ECG of such a big, dangerous animal with non-invasively, while it has had to be fixated before, and now you can have those vital parameters. This opens a lot of opportunities on research regarding also heart-related diseases on pigs. Yeah.
Thank you, Alex. That's all from me.
Yeah.
Thank you.
Actually, I was happy to learn from the researcher that there is the element of replicability, especially in case of cows. Since
Yes.
I'm from India, there is a foundation called BAIF, BAIF, Bharatiya Agro Industries Foundation in Pune. You could actually contact them, and maybe you can replicate it with cows. Actually, it's a very interesting thing. That's all from my side. Thank you.
Thank you so much. Maybe you could share the name of this.
No, you can actually Google it out. You will find it. BAIF, Bharatiya
BAIF.
Agro Industries Foundation, BAIF, from Pune,
Okay.
Maharashtra, India.
Thank you so much.
Okay. You can reach out and find out whether it is possible for you to collaborate with them. Yeah, for your further research and replicability. Thank you.
Thank you.
All right, we'll now move on to the next presentation. Next, we have Kotaro Kano, who will be presenting Evaluating Computational Thinking Ability of People Unfamiliar with Programming from Drawing Logs. Kotaro, you may now begin.
Hey. Share the screen. Can you see that?
Yes, we can.
Okay. Okay, good morning. My name is Kotaro Kano, and I'm first-year master's student at the Graduate School of Information Science and Engineering, Ritsumeikan University. Today, I will present our research titled Evaluating Computational Thinking Ability of People Unfamiliar with Programming from Drawing Logs. Before that, please understand that English is not my native language, and I kindly ask for your understanding and patience. First, I will briefly explain the research background and define computational thinking or CT. Next, I will describe our experimental design and analysis method. Finally, I will present the result and conclusion and summary. First, the research background. In recent years, computational thinking has become an important skill worldwide. In the United Kingdom, CT was added to the national curriculum in 2014. In Sweden, CT education using programming has been introduced for pursued teachers. However, most existing methods for evaluating CT using programming tasks. Because of this, it is difficult to evaluate CT in people who have no programming experience. There's still no established method to objectively measure CT in non-programmers. This study aimed to address that problem. We propose a method to estimate CT ability without using programming tasks. Next, I will explain what the computational thinking is. As shown on this slide, computational thinking is the ability to consider how to address a problem and develop a plan for its resolution. In other words, it means thinking about how to break down a problem, how to find patterns, how to simplify it, and how to design a clear procedure to solve it. These ideas are often summarized into 4 components: decomposition, pattern recognition, abstract, and algorithm thinking. Next, I will explain for estimating the CT. In this study, we focus on a flipbook drawing task using tablet application. In a flipbook, participants must create smooth motion by drawing across multiple pages. To do this, they need to think about what the final movement should look like, how to break the movement into smaller steps, how to assign each step to each page. This process requires planning, decomposition, and keeping it overall view of tasks. Therefore, we consider this task suitable for observing CT without requiring programming skills. Next, I will explain the experimental procedure. The experimental involved the 10 male members of our laboratory, all in their 20s. Participants performed the task using a tablet and electronic pen. We limited the number of flipbook pages to 11 pages. Without this limit, participants tend to draw without planning and kept adding pages. The page limit encouraged them to think ahead and plan the drawing process. During the experiment, we collected detailed drawing logs from the pen and tablet. Now, I will explain the task used in the experiment. Participants were asked to draw flipbook animation of a clock. The animation shows the hour and the minute hand moving forward in time. In experiment 1, participants created simple animation from 12 o'clock to 18 o'clock using 11 frames. In this case, each frame represents 30 minutes. This experiment helped participants understand the task flow. In experiment 2, the number of minutes per frame was not obvious. Here we estimated whether CT was being applied based on features extracted from the drawing. This slide shows an example video one of participant flipbook animation. It was like this. Next is the reason for adopting flipbook animation for the experiment. First, CT should be evaluated using tasks that require planning, not artistic skill. Second, the task should be fair and accessible to everyone. Tasks strongly affected by drawing skill are not suitable for CT evaluation. The clock flipbook task meets this condition. It requires participants to plan the movement of the clock hands to represent time progression. Therefore, it is very suitable for estimating CT. Next, I will explain the features collected during the experiment. From the electronic pen, we recorded pen elevation angle, pen azimuth angle, pen pressure. From the tablet, we recorded elapsed time, page number, and drawing coordinate. All data was collected every 0.1 seconds. This allows us to capture every fine grain and drawing behavior. From the collected data, we created several features, including pen speed, changes in drawing coordinate, and the absolute coordinate value. They are represented by clock hands. These features describe how participants drew and how their behavior changed over time. Next, we will explain feature refinement. Although we created many features from the data, some of them are highly correlated with each other. If highly correlated features are input into the model, as is similar information may be duplicated, potentially leading to biased learning or making interpretation difficult. Therefore, for feature with high correlation and coefficient, we organized the feature by excluding one of them. The right side slide shows a heat map of the correlation matrix, where darker red area indicate stronger correlations. So this process, we prepare the set of features that can be learned more appropriately. Next, I will explain analytical approach. This task involves drawing picture page by page like a flip book. In this case, the state of the picture drawn on previous page is so to strongly influence the state of the picture drawn on the next page. In other words, the drawing process can be set to possess temporal correlation. To capture this feature, this study employed hidden Markov model. By employing hidden Markov model, I believed I could estimate the hidden state underlying the observed pen movement and the feature, thereby modeling the drawing behavior. Next, I will explain the analysis. I will explain the analytical approach of this study. First, we divide the data into two groups, the city present group and the city absent group. Then we compare the difference in the latest state estimated for the city present and the city absent group respectively. We believed this would reveal difference in behavioral patterns between individuals with and without city. Finally, we analyzed the difference in the distribution of features obtained from both groups. This aim is to identify specific feature related to the presence or absence of city. Next, I will explain how the group without city were separated. The presence or absence of city was determined by observing the pattern of page transition and their temporal flow. The left diagram shows data with city. Page advanced sequentially with almost no backtracking, indicating planned progression. Conversely, the right diagram shows data without CT. It features frequent page backtracking with user returning to the same page to lead step. This reflects weak planning and ad hoc correction. Thus, we distinguish between CT and non-CT based on these page transition patterns. Next, I will explain difference in handwriting between people with CT and those without CT. First, we calculate variable importance using random forest model to identify the important feature. We found clear difference in several features. Because of time limit, I will show only two features. The left graph shows a pen speed. The right graph shows a pen angle. The blue line is a group without CT, and the red line is a group with CT. First, pen speed. The CT group changes speed smoothly and flexibly. This is because they draw with a plan. In contrast, the non-CT group shows very fast and very slow movement. This is likely because they use try and error and make many corrections. Next, pen angle. The city group tend to hold the pen at the lower angle. This means they often draw with the pen laid flatter. This may be because they try to draw straight line efficiently. They think ahead, so they do not need many corrections. On the other hand, the non-city group often drew curved and corrected their drawing. As a result, their pen angle tend to be higher. We also found difference in the future, such as mass and coordinate change, but I will not explain them today due to time limit. Finally, we summarize the conclusion of this study. The random forest analysis for extracting importance variables reveals the following features were strongly correlated with CT. The pen speed, elevation angle, azimuth angle, coordinate changes. In the group with CT, the following tendencies were observed: stable pen orientation, low and stable elevation angle, speed varying according to the situation, stable coordinate changes. These are thought to reflect deliberated drawing behavior. Finally, here is the summary of the research. This study proposed a method for estimating CT without using programming. By utilizing the feature extracted from drawing logs and HMMs, we demonstrated the potential to estimate the state of CT expression. This method is characteristic by its ability to evaluate CT from writing behavior without requiring specialized knowledge. Moving forward, we will verify the validity and generalizability of the method by diversifying subjects and expanding the scope of tasks. That concludes my presentation. Thank you for your attention.
Thank you, Kotaro. I don't have any question at this stage, but that is wonderful presentation, very informative. Thank you.
Thank
Okay.
you.
If you were to try out or do further research with other tasks, which tasks would you consider? Can you explain?
Thanks. Could you say it again?
No, you have described one task which you use, and you have mentioned that you intend to do further research using other tasks. So which other
Other
tasks would you
tasks.
consider?
Let me think. I try to do Unity coding and VR. Sorry.
Hello? I cannot hear you. Sorry.
Sorry.
Hello?
Sorry, just sorry. Staying at Oh,
Okay, it's all right. Thank you so much.
sorry.
All right, we'll be moving on to the next presenter now. Next, we have Dalila Martins, who will be presenting Exploring Player Experience, a qualitative analysis of narrative game reviews on Steam. Dalila, you may now begin.
Okay, can you hear me?
Yes, we can.
Okay. Give me just a second because I'm not able to share, I think. Give me just a second, please. Okay, I need to leave and come back. I'm sorry. That's okay.
All right, no worries.
Okay, can you see my screen?
Yes, we can.
Okay. Good morning, everyone. My presentation is about a qualitative analysis of narrative games reviews on Steam, which was authored by me and Professor Nelson Zagallo and Patricia Oliveira from University of Aveiro in Portugal. So, according to the literature, a high percentage of quality studies are focused on developer perspective in games, which leaves out the experience of perceptions of players. And to address this problem, textual reviews or comments can be analyzed to provide subtle information about the player experiences. The game design elements directly influence user satisfaction. So the reviews can be a direct evaluation of the product and influence the purchasing decisions of other players. So I would like to believe too many of you are gamers like me. So if you don't know Steam, I can tell you that Steam is one of the largest digital games distribution platforms and was developed by Valve Corporation. And what you can find here, you can find a lot of types of games, FPAs, RPGs, racing games, indie titles. You can purchase games. You have social and interactive features in the platform. You can have friends. You can follow developer updates. You can say if you like or don't like a game with positive or negative votes. And I don't know if you know, but comments also can provide additional information, such as a number of hours that you played, a number of comments that you submitted, and the number of games that you owned. Although there are a few related studies, I can tell you that for the example of Eberhard, that conducted that comments with higher usefulness ratings tend to be longer and use more complex language and express negative feelings. Lin conducted an empirical study analyzing more than 6,000 comments on Steam, focusing on the content and the relationship between the playtime and the comments. And more recently, Tong examined the correlation between player feedback and developer logs to determine the critical reliability of the community. So this study is about my doctoral research, and I intend to construct a design model for the engagement in the narrative games, and I integrate a component of community comments from Steam. I analyze case studies and I interview game designers in order to understand which elements in narrative games promote player continuity until the end of the story and their engagement. So this article presents a program designed to extract comments from Steam in a structured way in which the comments are output in Excel format suitable to systematic analysis. So academically, it is, I think, an advance in the qualitative study of game comments, a topic it is still largely unexplored. For industry, it offers game developers insights into understanding player perceptions by identifying current problems or valued elements that can guide game designer improvements. And together, these contributions lead to an understanding of the success of certain narrative games that can be transferred to other type of games, such as serious games. The process began with a deductive approach based on the dimensions of engagement scales, in this case, narrative scales from cell and the guess scale. Then we define, however, given the scarcity of tools for extracting comments of Steam, it was necessary to first define the criteria to guide the desired comment type. And then we developed an extract tool. Then we proceed by readability tests, given the high volume of comments and the involvement of more than one research in the coding. And finally, the data analysis was performed using thematic analysis. The game selected for the study was with the highest narrative completion rates that I found in another study, and are Spider-Man, Marvel Spider-Man, God of War, Horizon Zero Dawn, and Detroit. So the first step, as I said earlier, was to understand which scales could support this study. I did a exploratory analysis, and I found 80 scales, and I selected two: narrative engagement scale, and the GAS 18 scale. Since were no programs from extracting comments from Steam, I had to figure out what criteria was necessary for this study and which ones were already in Steam API in order to create the tool. I choose a lot of criteria, like a limit of comments, comments in English, reviews voted up, reviews with purchased games. They are not free and they are not reviewed during early access. I include the word story and narrative, and for example, I remove comments that I don't want repetitions or excessive use of characters. That is really common on Steam comments. With the support of computer engineering, Valve Corporation API was used to obtain data on games, including comments, through the endpoints and parameters identified in the documentation. A Java program was developed to filter, process, and export the data in the Excel file. And subsequently, 4 students improved the tool, creating a more attractive graphical interface and integrating new features such some AI and game comparisons. And these are some pictures of the tool. So after this preliminary data processing that was quite brief, we found the comments, and then we extract just the comments with some wrong information, and this was quite fast. But then we have more than 3,000 comments to analyze, and this was one image that you can see how the Excel is exported from the tool. This analysis was not done by me alone, and because of there are another analysts, it was necessary to perform a reliability tests. I would like to point out that before conducting this extensive analysis, I tried to analyze through the AI tools such as ChatGPT and Gemini, but unfortunately, they were not 100% successful. This was done in 2024, and I do not know if in 2 years later the tools would already have the necessary intelligence to understand some type of comments. So as I said, then we did the thematic analysis through the principles of Brown and Clark. And on the Bossell scale, which contains 10 dimensions: empathy, sympathy, loss of time, narrative involvement. As you can see, several themes were found, some of which were repeated. And you can see there are thematic like sense of presence and control, immersion in the game world, deep connection with the characters, for example, satisfaction with the game length. There are, okay. For the guess scale, which is more comprehensive and covers design elements such aesthetics and mechanics, it was possible to identify a greater number of themes. These themes tell us that players appreciate most in the games, analyzed in both cases. And in this scale, we can see a lot of more themes, different themes, like fun, enjoyment of mechanics, engagement with the game, story conclusion, balanced pacing, rewards, skill improvement, realism and details, etc. I think this study highlights the importance of a structured and automated approach to qualitatively analyze player feedback. And I think it also promotes the satisfaction of the players if you can know what they want and what they like. I think also with the development and application of this flexible tool, it was possible to extract comments from Steam and identify patterns that highlight the essential aspects of player experience. And as you can see, this study revealed more than 50 themes associated with the player comments. I also think that finally the study also serves as a bridge between academia and industry, because we can demonstrate how qualitative analysis of player comments can be used to improve games design elements like mechanics, aesthetics, narrative elements, in order to align the game with player expectations. And to finish, I already know there are a lot of limitations. I have a lot of subjective inherence in the qualitative analysis, since the review comments was conducted manually and associated with interpretation. I think I cannot capture the experience of players within different type of games. I just focus on narrative and in successful narrative games. And for future work, I think I can expand the sample and include another type of games to understand the players' expectations. I can compare other games with a lower narrative completion rates to identify the differences. And I really think explore artificial intelligence techniques for text analysis, in particular natural language processing models, in order to automate and improve the analysis of a large volume of comments. This is the references, and thank you.
Pragnya, you can ask question. I can do after that. If it is okay for you.
Sorry?
All right, I can ask. Dalila, thank you very much for a great presentation. I just have one question because it's a qualitative analysis. So as far I heard that you collected some, you did some interview, am I right? And you actually used the game designers. You did some interview for the game designers. Is that correct?
Okay, I did interviews with game designers, but it's in another phase of my project where I want to understand with the game designers also things like what they expect from players and what they like.
So my question is there any particular reason that you have selected only game designer? Because as far I know, gaming community is pretty wide. So why you have selected only the game designer as part of your interview?
Okay, because the project has three components. The case studies, that is my vision. The vision of game designers, that is in the interviews. In the about the industry and how they made what they think about the elements of game design, and then this phase about this article about community. And I want to merge all the feedback and understand which are the principles, which are the elements that are important to players and games and narrative games, because there is a issue to end a lot of narrative games, and they really quit fast sometimes.
Sure. Thank you. Just a small suggestion in future, you can talk with your supervisors or your academic people. I think because the gaming community is pretty wide, so even though you can think about academia who is actually working into the gaming industry, you can think them as part of your research collaboration, just for future
Okay.
data collection approach. Yeah, that's my
Thank you.
small suggestions. Yeah. Thank you.
Actually, I actually agree with you that yes, possibly, and also the players, like the age group of players, that also, like maybe that could be considered. No, that is
Yes.
very important, I feel.
Yes, they can be considered. However, my base of my project was understand what industry are doing successfully, and then transpose in the academia in serious games, for example, that are games for learning to change behaviors.
So sorry to interrupt, from that perspective, then what do you think is the targeted age group then?
Sorry?
What is the targeted age group of this industry?
The target of this group?
Yeah.
Yeah, basically, Pradni asking that what is the age range that you can select?
Yeah,
age. Okay,
exactly.
I really didn't thought about the age.
Exactly. Okay, no, I understand, because you also have to complete research within a certain time frame. Okay, that's all from my side. Thank you.
Thank you.
Thank you.
All right, we will now be moving on to the next presentation for today. Next, we have Romolo Paesani, who will be presenting heterogeneous IoT device integration through a digital twin framework and adopting the reactive programming paradigm. Romolo, you may now begin.
Okay, thank you. Can you hear me?
We can hear you.
Okay, let me share my screen. And let's begin. Can you see?
Yes, we can.
Okay. Good morning, everyone. My name is Romolo Paesani, and I'm from Gruppo SI in Teramo, Italy. Today, I'm presenting our paper on heterogeneous IoT device integration through a digital twin framework and adopting the reactive programming paradigm. This work is a collaboration between B2B SRL, Gruppo SI, and the University of L'Aquila. My co-authors are Gaetanino Paolone, Rodolfo Di Carlo, and Professor Paolino Di Felice. Let me give you a quick overview of what we'll cover today. First, we'll start with the motivation and the problem statement and present our research contribution. Second, we'll cover the necessary background on reactive programming and digital twin frameworks, presenting our 4-layer architecture, and dive into our case study called the Bazure system. Finally, we'll discuss result and conclude. The motivation behind this research stems from the growing recognition that digital twins can simplify IoT system development and management, but only if the data flowing from the physical to digital system is complete and accurate. Achieving this is harder than it sounds, largely due to the heterogeneity of IoT devices. Proprietary communication protocols make it difficult to establish common interfaces, and non-standard data formats hinder aggregation and analysis, and unpredictable data transmission timing complicates device coordination. The paper addresses these challenges by combining a digital twin framework with the reactive programming paradigm. Our paper makes three main contributions. First is seamless integration that refers to the smooth and efficient combination of different systems, applications, or components. In our case study, the seamless integration took place at two levels, between the physical system and the digital system, which is the system integration, and between two digital devices, which is the component integration. Second is the architecture, because we adopt an extensible architecture that separates the creation and management of the digital system from the control of the IoT devices. And third is the automation, because the implementation of the automation logic is based on events and configurable thresholds, with the addition of the reactive management of real-time data flows. The digital twin concept we refer to in this work follows the definition proposed by Tao et al. They proposed a conceptualization of DTs in terms of 5 dimensions: physical system, digital system, data connection, and services. Conceptually, the 5 dimensions comprise 3 parts: the physical system, the digital twin, and the connection between them. In the simplified view at the bottom, you can see these 3 parts: the physical system on the left, the connection in the middle, and the digital twin on the right, where the digital twin equals the digital system plus data plus services. The focus of reactive programming is the creation of responsive, robust, and scalable software applications by dealing with asynchronous data streams and propagation of changes. This application can adapt to dynamic environments by handling data changes and events in a non-blocking and event-driven manner. Reactive rules are logical statements that allow programming explicit behaviors and timely responses within the IoT system when certain conditions are met by incoming events. On the right, you see the Java technology stack we use. Spring Web Flux is a reactive module of the Spring framework that enables non-blocking operations. Project Reactor is the library to implement reactive programming through the Mono and Flux composable APIs. And Spring Web Client is the reactive HTTP client that integrates with the API I mentioned before, essential from consuming a real-time event stream such as server-sent events. In the IoT domain, reactive programming addresses the challenge of temporal unpredictability of data transmission because the reactive paradigm eliminates both limitations of traditional synchronous approaches. Because the devices publish telemetry and the system reacts to those events through stream of server-sent events. And the Flux-based pipeline processes the data asynchronously without blocking the threads. Now it's time to introduce Eclipse Ditto, which is our chosen digital twin framework. Ditto offers 3 key capabilities relevant to our work. First is standardization through the adoption of a uniform internal protocol for all device types, using a flexible, lightweight JSON-based model with attributes for static metadata and feature for dynamic state data. Second is flexibility, because Ditto is compatible with several external protocols for its connections, including MQTT, HTTP, etc. The last one is the real-time events through WebSockets and server-sent events. Here is instead our 4-layer architecture as implemented. At the bottom, the device layer with our 2 Shelly devices. Above it, the communication layer using REST APIs, servers and events, and MQTT broker called Mosquito. Going up further, we will find the digital system layer powered by Eclipse Ditto. And at the top, the application layer that uses Java with Spring Web Flux, Web Client, and Project Reactor. The case study I will present today concerns smart lighting systems. To demonstrate the effectiveness of the adopted four-layer architecture, the case study refers to an experimental scenario composed of the two heterogeneous IoT devices, a smart plug and a smart light bulb. An air dryer is connected to the smart plug. We call the whole IoT system the Bajor system. On the left, the Shelly plus plug S is a smart plug device that acts as a sensor, monitoring the energy consumption of the connected household appliance. It publishes consumption data to predefined MQTT topics and can be remotely controlled for on-off switching. On the right, the Shelly Duo RGBW is a smart lighting bulb used as an actuator that changes its color based on the power consumption, providing immediate visual feedback on the status of the monitored system. The experiment aims to show how to implement a multi-device automation logic penalized to shut down the smart light bulb when the predefined energy consumption limit is reached. The Bajor system implements two complementary execution flows that orchestrate the interaction between the data processor executor and the Shelly devices. The data flow describes the path of the telemetry data generated by the Shelly plus plug S towards the DPNE. The Shelly plus plug S, operating as an MQTT publisher, periodically transmits energy consumption data to predefined topics of the MQTT broker. The Ditto connections configured as a subscriber on these topics intercept messages and apply JavaScript transformations to convert the proprietary Shelly format into Ditto protocol compliant messages. This allows the continuous updating of the digital system. The DPNE receives a continuous stream of servers and events from the digital system according to the configured reactive rule. The command flow is the mechanism by which the DPNE sends commands to the Shelly devices in response to events monitored in the data flow. When the servers and events analysis determines that the automation conditions are met, the DPNE implements control actions through direct HTTP calls to the REST endpoints exposed by Shelly devices. And here is how a reactive rule is configured in the Bajor system. It's a JSON body of the API request from the client. The Bajor system is identified by the UID parameter. The smart socket measures the observed feature measurements and the observed property power drawn by the air dryer. Based on the level 1 watt and level 2 watt thresholds, the system updates the color of the bulb to denote the level of energy consumption. When the level 2 watt threshold is exceeded, a timer defined by milliseconds to shut down is started, which, when expired, turns off both devices. When the stop property of the specified stop feature reaches the stop value, the reception of servers and events for the Bajor system is stopped. The runtime configurability of the automation rules achieved through dynamic JSON parameters allows adapting the behavior of the Bajor system without having to modify the DPND software. All the parameters is fully configurable. The DPNE, data processor and executor, is the software which implements the proof of concept. The DPNE is organized into three packages. The control package intercepts client requests and passes them to the service package. The service package integrates business logic and communication with both the Shelly devices and Eclipse Ditto, and moreover, it orchestrates the operations required to update the respective digital system and execute the reactive automations. At last,
Excuse me.
support.
I'm sorry to interrupt. You have 2 minutes left.
Okay. At last, supporting packages provides a function that facilitate the overall operation of the TPMP. Very important to mention is device service interface, which serves to standardize the basic operation of two devices. It's specialized by two classes, each one representing a device, ensuring uniformity in the treatment of both devices, despite their different functionalities. Now let's discuss how the challenges listed in the introduction were met. For seamless integration by adopting a common interface, as mentioned before, and using Eclipse Ditto as a mediation layer. In this way, the Bazure system masks the underlying heterogeneity of the device because the plug and bulb are uniformly represented in the digital system through the Ditto Think model. At last, the event-driven MQTT-based approach ensures that integration does not require direct coupling between Bazure system components, promoting the scalability and maintainability of the digital twin system. For the architecture, the conceptual separation allows modular software organization, which allows for the independent evolution of its components. The architecture supports both synchronous operation for managing Ditto entities and asynchronous mechanism for the real-time propagation of events. For automation, reactive programming eliminates the need for continuous polling, replacing it with a model based on event streams. These optimize the use of computational resources and ensures a near instantaneous response time to critical events. At last, the runtime configurability of the automation rules allows adapting the behavior of the Bazure system without having to modify the DPMP software. In conclusion, we have illustrated how the integration of established open source technologies, Eclipse Ditto, MQTT, Spring Web Flux, produces an effective solution that ensures interoperability between the physical system, the digital system, and the heterogeneous devices in the deployment of IoT systems. Thank you very much for your attention.
Thank you, Romolo. Do you mind if you actually go to slide number 10 for me?
Slide number 10, yes.
Yeah. I would like to hear a little bit more about the Mosquitto broker and Ditto connections. Can you just elaborate a little bit?
Yes. The connection rule is a rule configured into Ditto. We write the JavaScript function to convert the proprietary interface in the property language of the Shelly device to a language comprehensible to Ditto framework. So we in this way we can permit to talk each other to the Ditto framework and the Shelly device.
Thank you. Romolo, just a last question. If you move into the second last slide, you talked about the scalability.
Yeah.
Yeah, I just would like to know that the third sentence from the first paragraph, it says, you said the promoting scalability. Are you talking about the business scalability or are you talking about the system scalability? It says event-driven approach, no direct coupling, promoting scalability and maintainability. So I would like to hear more about scalability. Is it business-related, business scalability? That means, are you talking about the enterprise or industry, or are you talking about a particular system?
We talk about scalability of the entire device sector, because with the device interface we we can integrate more devices with the different classes and different producers. So the scalability is in terms of the number of the devices that we can integrate into the system.
Thank you, Romulo. That's all from me. Thank you very much.
Thank you.
Okay, that was an interesting presentation. No comments from my side. Thank you.
Thank you.
All right. So our last presentation for today is by Napat Suktong, who will be presenting Privacy-Preserving Federated Learning with Explainable AI, P2 Flex for Enhanced Multi-Center Healthcare Data Analysis. Napat, you may now begin.
Okay. Right. Good morning, good afternoon, and good evening, everyone. I'm Napat Saktong from Mahasarakam University, Thailand. Today, I'm excited to present P-Square Flex. It's a framework designed to bridge the gap between the high-performance AI and critical need for privacy and transparency in healthcare. We aren't just building a better model, we are building more trustworthy one. Let's address the elephant in the room, the healthcare AI paradox. On the one hand, clinical AI needs massive, diverse data to be robust. On the other, patient data is rarely so, locked away in legal silo like, let's say, HIPAA and GDPR. Currently, we are forced to choose centralized models, which are powerful but often illegal, or single-site models, which are legal but suffer from bias and poor generalization. It's a choice between performance and privacy. And frankly, we need both of them. Even if we use federated learning to solve the scale issue, we hit a second wall, that is the double black box. Layer one is the model itself. It's complex neural networks that are inherently opaque. The second layer is the federation. Clinicians can see where the updates are coming from, creating a trust deficit. Without interpretability, AI remains a research concept, not a clinical tool doctors can actually rely on. This is where P-Square Flex comes in. Our core philosophy is to explicitly tackle this double black box. We hypothesize that by integrating post-hoc explainable AI or XAI into secure federated learning, we can actually outperform single-site models in generalization while finally winning clinical trust. We are making transparency a feature, not an afterthought. Here is high-level view of how P-Square Flex works. The golden rules here is simple. Raw patient data never leaves the hospital. We only transmit encrypted gradients through a secure channel to a central server, let's say. The server performs secure aggregation and sends a global model back to the local sites, where clinicians receive not just a prediction, but a full interpretability report. Our first pillar is federated training using the Fed average algorithm. Think of this as leveraging collective intelligence without data exchange. We initialize a model, train it locally on non-IID data across different hospital demographics and only share the updated weights. We learn the patterns of the whole population while respecting the privacy of the individual. To ensure privacy by design, our second pillar is secure aggregation. We protect against gradient inversion attacks by using the CKKS protocol. We use CKKS over BFV because it is optimized for the floating point tensors standards in machine learning, offering high efficient without expensive conversion costs. We also add differential privacy or DP as a second layer of the calibrated noise for maximum security. The final and perhaps more important pillar is the trust bridge. We use techniques like Chap and Lime to convert opaque probabilities into critical rationale. Instead of just saying 85% risk, P-square flags show the doctor why, for example, plus 20% due to high glucose or plus 10% due to age. This allows doctors to validate the AI against their own medical expertise. To prove this works, we simulated a realistic heterogeneous environment using real-world clinical care data from MIMIC-4 and EICU. We apply theoretical partitioning to mimic the natural feature and level skew find in different patient populations. We didn't want a lab perfect scenario. We wanted let's say, hospital messy one. Our strategy is to prove value against both the status quo and the idea. Baseline one is the single sign model, our flow. And the baseline two is the centralized model, the theoretical but illegal stealing. The goal for P-square flex is to match that centralized performance while maintaining the privacy compliance of a single site. We measure success through three lenses. Predictive metrics like event score and AUC for the generalization by testing the global model on holdout hospital data. And the last is security overhead. We are closely monitoring the runtime and bandwidth costs of CKKS encryption to ensure this system is actually feasible for real-world hospital networks. Because this is for healthcare, numbers are not enough, We utilize the ClickM framework for clinician-informed evaluation. We measure the correctness against medical ground truths and conduct user studies to see if XAI augmented decision actually improve clinician confidence compared to black box results. We anticipate three major impacts, as you can see here. First, superior generalization by mitigating institutional bias. The second one is scalable security that isn't a burden on, let's say, hospital IT department. And the last one is the safety value, where XAI help us catch spurious correlations, like a model accidentally learning to recognize an equipment artifacts instead of a disease. That's happened before it ever touched a patient. Ultimately, P-square flex represent a paradigm shift. We are moving away from black box authority and blind trust toward transparency decision support with humans in the loop. This architecture is designed to be HIPAA and GDPR compliant, unlocking the next generation of collaborative healthcare AI. Looking ahead, we are exploring personalized federated learning like FedProc, FedNova, or for extreme data differences, and fully homomorphic encryption for end-to-end compute. And I think that's all from my presentation. Thank you for your attention. I have provided my contact details and link in here, and I look forward to your question. Let's build future where I believe AI is as transparency as it's powerful. Thank you very much.
Hi, Nipat. Thank you very much for your great presentations. Very, very interesting topic. Do you mind if you go back to the previous lecture slides? Just slowly go back because I can't see the slide number. That's why I can't tell you the slide number here. If you can slowly, I think it's the first slide. Yeah, from the beginning. Just one question I have in my mind where it shows the hospitals. Yes, can you stop in here?
Okay, yeah.
Yeah, go to the, yes. It's just my general questions. You selected the hospitals, but in your abstract, you mentioned that distributed healthcare institutions. So it's my understanding is the healthcare institutions are pretty wide. So you can think about medical center, you can think about specialist, general practitioners, even think about the pharmacy. They are also part of the healthcare provider. So my question to you, are you focusing only the hospitals or are you focusing in general all the healthcare institutions?
Well, because the idea of my research is I follow the UK's NHS system, because the peace conflict is much in line with the UK's current strategy, specifically the shift from data sharing to data access within the NHS system. How it is compared, just like the UK, I can't remember what it's called, secure data environments or SDE. Peace conflict ensure that the raw patient data remains at the local hospital site and never leave its original jurisdiction, And why many UK systems rely on centralized secure environment? Peace conflict use federated learning to allow model to learn from the multiple center simultaneously. So from your question, you asked that my system will support only hospital or not? No, yes, because my system can conclude the medical center or the pharmacist if it's the law allow them to join the system in the future.
Sure. Nipat, then if you move to the next slide, I have one more questions. If you go to the next slide. Yeah. So when you say hospital A, when you say hospital A, demographic hospital B, C, and D, are you talking about a specific region or are you talking about the entire country?
At the first step of my research, I interpret the demographic is from different province, from different area. Yeah.
Okay. Yeah. Okay. That's fine. Thanks. That's all from me. Thank you again.
Thank you very much.
Yeah, I have no comments to make. Thank you.
Thank you very much.
All right, so with that, we'll move to the end of this session. I sincerely thank all our authors for their excellent presentations and contributions in this session, and all our participants for being a part of this international conference. I hope the session was informative for everyone, and on behalf of the whole team, I thank you for your support during this 11th version and all the previous 10 versions of the conference. We will be happy to have you in the 12th version in 2027. All the presenters would be getting their digital certificates through email within 2 working days, and the publication will be live within 7 to 8 months. Kindly cooperate with the team of ICICT 2026. I also thank our chairs, Shakir Karim and Dr. Pradnya Chitrao for chairing this session. We would like to present a token of appreciation to the chair on behalf of the team ICICT 2026. Just 1 second. Thank you, chairs, for your valuable presence. I kindly request everyone to switch on their cameras for a quick virtual snapshot of the meeting.
Thank you so much. I'm having a few, actually, you see, internet issues. So switching on the camera will actually, so thank you so much.
All right, no worries, ma'am.
Thank you.
All right, thank you so much, everyone. Stay safe and take care.
Thank you.
Thank you, everyone.
Thank you.
Have a nice one.
Thank you.
Thank you. Have a good day.
Thank you. İstanbul'dayım.